Okay, so question 3, carrying on with the conservation of mass questions. We've got a student this time taking some sodium carbonate powder and heating it on an open crucible. So they're taking sodium carbonate here and they're heating that up. The student has measured during the course of the experiment that the mass of the powder has gone down, and what she said is that this must be wrong due to conservation of mass essentially being conserved during a reaction. Basically, the measurement is not wrong. That's the straightforward answer. And the reason being, sodium carbonate, the left-hand side, is a powder, it's a solid, as is sodium oxide. And so if you start heating up sodium carbonate in a beaker, then you will be heating up some sodium carbonate on this side of the experiment. You then proceed to heat that up and you will be left with some sodium oxide. That is correct. So there will be some sodium oxide here. And what she said is this is less and therefore the experiment must be wrong because it should have been the same as it started with. Now the problem with that is the extra product is carbon dioxide. It's undergoing a thermal decomposition here. And what's happening is during thermal decomposition, the carbon dioxide is given off. And carbon dioxide, as we know, is a gas. And so the carbon dioxide has essentially come out of the beaker that she has subsequently weighed. So she was correct in the sense of mass must be conserved, and it will be conserved, but the mass which has been lost will still be in existence. It's just not in the beaker anymore, and so it's floated away somewhere. However, the carbon dioxide which has been released will equal the mass lost. So the mass of the sodium oxide which has been produced plus the mass of the carbon dioxide will equal whatever that was. But in terms of experimental measurements, the mass of the solid which has remained will be less because this carbon dioxide gas has essentially floated off somewhere. So she was correct in one sense, but incorrect in the sense of what she was doing during the experiment. Okay, so she's calculated, as we've gone along, the relative formula masses of the reactants and products. And sodium carbonate, which is the Na2CO3, was 106, and the molecular mass of carbon dioxide was 44. Now, we're being asked to calculate the molecular mass of sodium oxide now. If we look at the equation, we know that the sodium carbonate is on the left-hand side of the equation. That's 106. And that is going to produce sodium oxide, which is the question, plus the carbon dioxide at the top of the equation, top of the page, which we are told in the question is 44. And simple mathematical manipulation can work out that 106 subtract 44 is equal to 62. Okay, and so that can be calculated as being the molecular mass of sodium oxide, but it would be nice to just check it. We know that from using a periodic table, we know that if we've got 2 sodiums and 1 oxygen, sodium weigh 23, so we'd have 2 lots of 23. We'd add on a 16 using the periodic table, and we'd then have secondary confirmation that 23 at 16 does also equal 62. But when the equation is 1 to 1 to 1, we can do a simple addition of the molecular masses. It's not always that simple. And more complex equations, we can't do that methodology, but in simple situations like this, we can just do a relatively simple mathematical subtraction or addition.